Hello everyone, we are Namiki Laboratory in Chiba University. For now, we'd like to present our research, real-time tracking of origami with physics simulator considering fold lines. Manipulation of a deformable object is a difficult problem for robots. In particular, paper is a difficult object to be manipulated because, in contrast to cloth, it has bending elasticity and plastic deformation. We have been studying robotic paper folding and succeeded in very triangular folds. However, the paper shape was not accurately estimated, and it was difficult to achieve more complex folds. Here's an overview of our paper shape tracking system. We mount inter-real-sense RGB-D cameras at 5 viewpoints, and the Vision PC runs a real-time digital twin simulation with two processes called tracker and simulator. We extract the paper region from the RGB image and obtain its shape as a point cloud. In parallel, a physics simulator predicts the paper's 3D deformation. We registered, measured, and simulated point clouds using coherent point drift. The simulation method uses sub-step extended position-based dynamics. The paper is represented by a mass link array model where each link includes a spring and damper. To capture irreversible deformations such as creases, plasticity is incorporated into the springs. However, this model presents a trade-off in plasticity. Increasing plasticity makes the paper deform more easily, but it also reduces robustness to input noise from the tracker process. To resolve this trade-off, we localize plasticity. We first perform node clustering to detect fold lines as cluster boundaries. Clustering uses k-means with Mahalanobis distance constraints so that clusters form approximately planar distributions. We then determine whether a link lies on a fold line from the cluster labels of its endpoints and apply plasticity only to links on the fold lines. For evaluation, we conducted real-time paper tracking in a physical setup. The manipulation follows square-based folding. As a result, we successfully tracked a full sequence of folding. However, because collisions are not modeled in the simulator, model tunneling occurs. As feature work, we will address the model tunneling program while optimizing system parameters and accelerating processing. For more details, please visit our poster session. Thank you for watching.